Welcome, everyone. I'm Jen, Group Manager of Strategic Marketing at Panasonic Industry. It's great to have you with us today as we dive into our webinar on FineX Transparent Conductive Film. I am pleased to introduce Simon Wong, one of our product engineers in Panasonic Industry, who will be presenting today. Simon directly supports customers in our electromechanical product team. Earlier in his career, Simon worked in the aerospace industry testing and tuning RF circuits before transitioning into software testing at a defense company. And then in 2022, he joined Panasonic Industry. So with that, Simon, I'll hand it over to you.
On our agenda today, we'll be covering three main topics. First, we'll discuss EMC and EMI design challenges, which will include real-world noise problems that engineers face, as well as case studies for specific applications such as industrial equipment, RFID applications, as well as facility design. After that, we'll introduce Panasonic's FineX Transparent Electromagnetic Shield, which can be used as a great solution to these EMC design challenges. We'll discuss its unique fine wiring technology, which can provide both high transparency as well as superior shielding performance, and we'll talk about how it can be implemented into your design without compromising product aesthetics. Lastly, we'll discuss some application examples of how FineX can be used in specific use cases, as well as some implementation guidelines for specific designs. So first off, let's do a quick introduction of FineX. If you're not familiar with FineX, it is essentially a transparent conductive film. What makes FineX unique is that it is capable of both high transparency and high conductivity due to its low resistance. Generally, similar types of products have a trade-off between the two since you need more metal material for lower resistance, which lowers the transparency. However, with our unique production methods, we can achieve low resistance without sacrificing transparency. This type of transparent conductive film can have a lot of different use cases. Some example of the applications this product can be used for would be transparent shielding, transparent antenna, transparent heaters, dimmers, or as a substrate itself. For the purpose of this webinar, we're going to focus solely on the shielding application, so as an electromagnetic shield. However, if you have other applications you are interested in, please feel free to ask any questions in the chat or feel free to reach out to us directly. For our next section, we'll discuss market trends when it comes to EMC compliance. In today's world, telecommunication technology usage is ever increasing. Because of this, regulations on electromagnetic compatibility, or EMC, are becoming stricter and stricter as more devices enter the market. As wireless device usage as well as data rates increase, it becomes more and more important to have your products comply with EMC standards to prevent network interference. As you can see on this chart, the number of standards or regulations have been increasing steadily throughout the years, and today's wireless devices have to comply with more EMC standards than ever. If we take a look at this chart, you can see how EIC, CRISPR, EN, and FCC standards have increased from the 1980s until now. As new markets emerge and mature, new regulations will naturally follow and expand as well. In our next section, we will discuss the concerns with electromagnetic compliance in applications such as industrial equipment and RFID. When it comes to EMC, it is comprised of both EMS and EMI. EMS stands for electromagnetic accessibility and represents how resilient your product is to external noise, while EMI stands for electromagnetic interference and represents how much noise your product emits. When it comes to compliance, making sure your product is not susceptible to noise and also not generating noise is very important. In industrial equipment design, noise can be generated in many places and they have different types of countermeasures as you can see on the chart to the right. The main area where FineX is focused on is for areas like housing openings, such as transparent windows, ventilation holes, or displays. It can be difficult to achieve the right balance between visibility into your product, as well as implement proper noise countermeasures, and FineX really shines when noise prevention is needed while keeping the display or window transparent. Another issue or concern that we've been seeing is for applications like RFID readers in something like an assembly line or warehouse. With RFID readers, it can be difficult to prevent misreads, like in this example where the tags on boxes in area B are being accidentally read, as well as the boxes in area A. Some countermeasures that can be implemented can be something like an antenna gate reader or a metal hood to block the RF waves, but this inhibits visibility. In the slides later on in this presentation, we'll show how fine cross can be used as a perfect solution for a problem like this. When it comes to noise countermeasures, it's generally taken into account during the initial design phase. However, with the nature of engineering, problems can arise after initial evaluations find that the product is not complying with EMC standards. When this happens, urgent countermeasures or late-stage design modifications are needed. Fine cross is a great solution in these cases since it can be simply applied to surfaces to be used as a shield without additional wires or connections needed. This will help save a costly redesign for the end product. When it comes to conventional EM shielding methods, metal foils or ITO films are commonly used solutions. However, these both have their own drawbacks. With metal foil, the shielding performance is very good, but it is not transparent, so you cannot see inside your product. With ITO film, it can be very transparent, but the shielding performance is not as good. In the next slides, we'll be highlighting the specs of fine cross and how it can achieve both high shielding performance and transparency without any trade-offs. Introducing the Fine Cross Transparent Shield. Panasonic first released Fine Cross as a standard part number in October 2025 and is currently available through Digi-Key and Mouser. If you take a look at the chart on the right, you can see how Fine Cross compares to other types of shielding technologies. Generally, transparency decreases as shielding performance increases, following kind of like a downward trend line. With Fine Cross, we can target this new area of applications that require both good shielding performance as well as transparency. Here are the basic specs of our standard product compared with some specs for conventional etched metal meshes. Some of the important things to note is that we can achieve a wiring width of 2 micrometers, which is invisible to the naked eye. The transmissivity is around 89%, and the sheet resistance is around 2 ohms per square. Of course, with these types of products, sometimes it is necessary to customize the film, and that's something we can do as well. The sheet itself is around 18.78 by 20.93 inches. It comes with an OCA, or optically clear adhesive, which makes it easy to mount to things like displays or windows. It is also unnecessary to ground the sheet since it works through EM reflection rather than absorption. Fine cross is made through a proprietary roll-to-roll process. It starts off as a roll, where it gets grooves embedded into the base film. Copper wiring is then wired into the grooves as it rolls back up to complete the final product. To expand a bit more about the structure of the metal mesh, you can see how it compares to other technologies. With ITO, or Indian tin oxide film, the metal is deposited on top of the film and the resistance is not quite as good. With other metal meshes, the metal is etched on top of the film in a crisscross pattern, which results in poor visibility due to the intersection area and thicker lines needed to achieve the low resistance. With fine cross, the metal is actually set into the grooves, which gives it a much higher aspect ratio. This higher aspect ratio allows for higher transparency due to its lower width, and still allows for low resistance since we're utilizing the depth for more metal material. This lower resistance is what allows for a better shielding performance. On this slide, you can see an example of the shielding performance across a wide range of frequencies. We've tested this all the way up to 40 GHz using standard tests like the KEC method and free space method, and as you can see, the shielding efficiency performs quite well across the entire range. As a quick reference, we've done some tests comparing the shielding performance of ITO films and other metal mesh films to fine cross, and you can see the results here. The shielding efficiency is on average 10 to 20 dB better than the next solution, depending on frequency. Earlier, we discussed some potential EMC issues with specific types of applications. Now that we've discussed some of the basic specs and advantages of fine cross, I'd like to go back to some of these issues that we brought up in the earlier slides. Here are some example use cases of fine cross and how it can be a good solution for these applications. In the case of industrial equipment, where motors can generate lots of noise, or the end product can be susceptible to EM waves, having fine cross over the window can allow the user to still look inside the equipment or testers to verify current status while still blocking EM waves. For RFID applications, by adding fine cross to something like a transparent divider, we can easily solve the issue with misreads by placing it between different areas. Some other areas where a transparent shield can be helpful would be in cases like factory automation equipment as a protection hood, RFID applications to prevent interference. Factory windows is another good one to prevent noise leakage, and also server racks to ensure reliable networking. Fine cross can be easily implemented to various applications. It comes with an optically clear adhesive applied to it, and you simply stick it onto your product after removing the protective film with no wiring needed. Next, we'll quickly show a video demonstrating fine cross when it comes to RFID applications. In this video, the RFID reader is constantly beeping as it detects the tag. You can see how effective fine cross is in blocking this read when used on an acrylic box. As you can see, the beeping stops as soon as the box is placed over the tag. In our last section, we'll be going over some application examples for fine cross, as well as some implementation guidelines. In this first example, we have industrial equipment. For this type of application, you would apply it onto the windows so that you can still see inside the machinery. This prevents noise leakage, as well as interference from outside noise. In a case like this, you can simply apply the fine cross on top of the glass on the window. Another great example is for monitors or displays. Generally, monitors can generate unwanted noise, and the touch panel can also be affected by external noise. This can be prevented by sandwiching the fine cross in between the display and touch panel. For RFID applications, a simple solution to prevent RFID misreads is by placing it on a transparent divider, similar to our demonstration video earlier. In this case, you can just simply stick it onto the glass with the applied adhesive. Lastly, we have facilities or factory buildings where fine cross can be applied to the windows. This will prevent noise leakage and external noise interference while allowing factory workers to still have visibility into the room. In this case, fine cross can be sandwiched in between glass or simply pasted on one side. Thank you for attending this webinar, and now we'll just give a quick summary of what we went over today. Here are some key takeaways that I hope to leave you with today. EMC risks generally increase with higher frequency and system density. Traditional transparent shields generally force trade-offs between visibility and performance. Fine cross provides a balanced solution to this with high transparency and effective EMI shielding. Some gray areas where fine cross is applicable would be for visibility critical applications where EMC countermeasures are needed, such as windows, displays, RFID control, or visible openings. Lastly, fine cross is a great solution for late-stage EMC fixes as an alternative to making redesigns. Our standard product is available currently through DigiKey and Mouser. I've included links onto this presentation, which will be sent out. If you have need for other requirements or something more customized, please feel free to reach out to any of us since that is a possibility as well. Something more customized, please feel free to reach out to any of us since that is a possibility as well. For some additional resources, We have some links that you can access on this presentation that we will be sharing with you all. We have a landing page that gives a high-level overview of our fine cross, as well as a blog post. We also have a quick introductory video as well. Lastly, we have some additional blog posts below, a nice brochure specific to shielding applications, and lastly, our fine cross solutions video.
Panasonic Industry